Okay. Hey folks. So I want to do something a little bit different today. A lot of times when I look back at older puzzles, I try to grab ones either I don't remember or I uh, remember a little bit of, but enough that I'm still solving most of it. I remember how this puzzle works. Um, this is Whoa, I Know Prestidigitation from the 2003 MIT Mystery Hunt. It was part of one of the training modules available in it. And this is, in terms of a puzzle, it is actually fairly straightforward. You do exactly what it says. You take a deck of cards, you put them in the starting order. This is theoretically done with a brand new deck of cards, but they also included here what order you put it in through ace through king of hearts, ace through king of clubs, so on and so forth. And then you perform all of the various things with it. Um, uh, this puzzle is really important to me because this was something when I was in like middle school and high school when I first found out about the mystery hunt. Uh, this was a puzzle that I could do, right? Um, this was a puzzle that definitely like ninth grade, 10th grade me was like, all right, I could do this and started doing it. And if you haven't done it yet, certainly trying to go through this manually is definitely a thing you can do. There's a various number of perfect shuffles that you have to pay attention to, but it is in the end very much uh, yeah, it is a series of steps that you can easily do. Uh, it just takes a little while. Well, I've been on a kick of trying to deal with learning to code recently, and part of that is like, well, it is useful to be able to just like quickly write code for various different puzzle hunt stuff. Now, it's not actually that necessary for Mystery Hunt because if I need someone to write code for MIT Mystery Hunt thing, my Mystery Hunt team is filled with programmers. So I've been able to get away with it, much like when I was on Palindrome. I could get away with never learning how a cryptic clue worked because Palindrome has 5 million cryptic solvers. But most Mystery Hunt teams have some decent programmers. So it's not necessary for a mystery hunt purpose, but it's important to have. I want to have a variety of solving skills, and doing programming is important for that. Now I have the ability to do like basic programming on a variety of different languages, but I've been picking up Python partially because I want to start learning Django because when 2022 came around, one of the big weaknesses I found I had that I really wanted when writing puzzles was that I wanted the ability to be able to write server side stuff and not client side stuff. I constantly had to keep asking people to write my server side code. So basically, it's a long story short, a long way of saying that like I am trying to do uh, writing code for puzzle reasons. And a great way to do that is just to go and look at old puzzles and try to write code for them. Uh, and that's also a thing. If you're looking to get better at current mystery hunt puzzles, I honestly recommend that you go back and look at older mystery hunt puzzles. Um, because older mystery hunt puzzles, especially in like the 2000 to like 2008 ish era. I have that as an era in my mind because I started hunting in 2009. But like the puzzles were more straightforward, right? Like we certainly have evolved what can constitute a puzzle, what can constitute a meta since then. And that's not to say there aren't hard things in there. That's not to say there aren't they aren't good puzzles. They absolutely are good puzzles, but they definitely are great for like getting a step up into what you're doing. Okay, so that's a long way of saying I'm going to resolve this puzzle, but I'm going to try to do all of this via coding, so I don't have to do all of this by hand. Okay, So I need to represent a deck of cards. And then I have 5 functions. Perfect shuffle. Put top card on bottom. Discard top card. Exchange top and bottom cards. And flip top card over. Okay, so each card is going to have the properties that it's the cards. The properties that they're going to have are the suits, value, face up or face down, order in the deck. Now, I could have the card's object be ordered, but I kind of don't want them to be. So I guess I could have the order. Maybe I could have cards as an ordered. Yeah, maybe I do want cards as an ordered object. Ordered thing. So, not object, I'm using Python, but. So if I have, let's just say, an array of cards. Oh, I should mark these as 0. They're numbers. All right, so let's say I have an array of cards and they're ordered. So some of these are going to be easy. And let's call them equal. This is deck. So then some of these are easy. Flip top card over is just deck. We'll call it facing. This is probably a dictionary. So deck.get facing equals deck.get equals not deck.get facing. And I have to figure out, I'm using this, but I don't know if that's the actually Python not symbol. I haven't needed this yet, so. Okay. It doesn't use. Okay, just the word not. All right. Okay. Python, can we just get rid of an array item? Oh no, it would be okay. It would be. I'm just gonna say iterate over length of deck iterate 1 to deck.length. We'll figure out the actual. I forget if that's a thing you can do it. Like if deck. It's like range. It might be like -1 if I do it correctly. How does an array deal with Python array remove elements? Is there just an easy way of pop method? Oh, okay, so you can just use pop. Okay, cool. All right, well, discard top card is just deck dot pop 0. That's easy. So then this could be new deck equals deck dot pop 0 dot pop length. It's deck dot length, right? Oh, you need to use len. Okay. And then oh wait. Oh, adds an element at the specified position. Okay. So does this shift everything over? Yes, it shifts everything over. Great. So then new deck equals new deck dot insert 0 deck len deck -1 new deck dot insert actually just append deck 0 and then say something like deck equals new deck. And that should exchange the top and bottom. So this makes a new array that this takes the deck out of everything but the top and bottom cards. This says put the bottom card of the deck on top of the new one. This one says take the top card of the deck and put it on the bottom of the new one. And then this is, hey, now the deck should be equal to this new deck. Oh, this needs to be deck 0. Because it's the top card. Okay. Put top card on bottom. Deck dot append deck 0 deck dot pop 0. That should make a copy. It should put the top card on the bottom. I'm just really hoping that this is not like creating a pointer to this object and then this is deleting the object. But I'm assuming I don't have to mess with pointer stuff because I'm not like doing C. All right, perfect shuffle. So if we do a perfect shuffle, this is the one that's complicated. So the top card goes second, the bottom goes second from the bottom. So the problem is that I was gonna you can't hit it to 52 cards because like we shuffle and then we do discard top card immediately after, and then we do another perfect shuffle. Is it always an even number of cards? It looks like it might always be an even number of cards. Yeah, okay. Let's assume for the moment it's an even number of cards. We'll say if land deck. Please tell me. I haven't used modulus in Python yet. I have not done a lot in it. Okay, it still uses percent sign. Great. Modulo 2 equals 1. All right. Okay, so then let's just do the math on this for a second. So, okay. Do the math on this. So, if we have like a 10 card deck, so it gets split into piles 1, 2, 3, 4, 5, and 6, 7, 8, 9, 10. And then we put 5 on the bottom, and then 10 on top of it, and then 4, and then 9, and then 3, and then 8, and then 2, and then 7, and then 1, and then 6. Is there a function that we can create that will spit this out, obviously using mod 10? Well, yeah, so there is. So okay, I realized that I did this incorrectly because I should be zero indexing everything because we're going to be using mod 10. Um I should be zero indexing things because we're doing things based on the array index. So let's try this again. Actually, I could just retype this based on the just subtracting one from everything. I don't need to go through the whole process again. And so now this is on 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't need to worry about monospacing that right now. Okay. So 5 needs to go to 0, 0 needs to go to 1, 6 needs to go to 2, so on and so forth. Now, if we multiply by 2, these are all correct, and these are all need to get added by 1. So if we take input times 2, plus okay, something, and then we stick that all mod 10. length. And that'll equal the output. All right, so now this needs to be an expression that is 1 if the number is less than half, and 0 if it is half or greater. Can we do... Ooh. Okay, so theoretically, we don't need to worry about the difference between this, and I can just say 1 minus input divided by length divided by 2. Right, input divided by length minus 2 is going to give us 0. It's going to give the opposite of what we want, so if we take 1 minus, it's going to do that. All right, that's actually... that would be nice. That's going to be the first thing I want to test, actually. So let's go create a puzzle prestidigitation.py. All right. For input in test, print input times... actually, I'm gonna stick it in a different... so output equals input times 2 plus 1 minus input. So this should be 0 to 9. Len test divided by 2. We need parentheses here. And then this needs parentheses mod len test. Okay. And then print input plus output. Oh, right. I need to change these to string. Nope, that didn't quite work. It's adding 1 to everything. All right, I'm actually just going to get rid of this for a second. Oh, is that am I failing at how range functions? Yeah, okay. Let's try that again. Good old case of the test is not working. Okay, this is all giving me these like ugly floating points though. Like, yeah, that's gonna. Yeah, as much as I like this, I'm gonna change it to int. Yeah, it just gives me integers, and it gives me 0 is 1, 1 is 3, 2 is 5, 3 is 7, 4 is 9, 5 is 0, 6 is 2, 7 is 4, 8 is 6, 9 is 8. Great. Okay, so. Okay. Well, okay, so that's not the whole thing. This is going to be. All right. Oh, lists. Sure, it's actually a list. Yeah, yeah. I forget that they're called things in here. Okay. They can contain different. Yeah. So then what I do is I say, okay. Where are the like? There's like the constructors. Yeah. I need to be able to create a list. Can I just have it create a blank list of a specific? No. Okay. I mean, maybe I can. I just don't know how to do it. But this should work if I do something like new deck equals is range puts out a list, right? I could just okay. It returns a sequence. What kind of item is it? Oh, actually, no, no, no. We say okay. New deck equals deck. this is how we do it. Duh. Okay. Yeah. New deck equals deck. For um for yeah, all right, just iterate over range 0 len deck. We do this. New deck output equals deck input. And then when it's all done, deck equals new deck. Okay. Okay, so now we've defined all 5 functions. Okay, yeah. So at this point, I think I'm ready. Like, now that I know what I need to do with these, I can just start actually coding things. All right. Uh, deck equals for. All right. I remember this. Suits is equal to. What's the order in this puzzle? Hearts, clubs, diamonds, spades. Cool. Hearts, clubs, diamonds, spades. Values equals A, 2, 3, 4, 5, 6, 7, 8, 9, T, J, Q. Okay, there we go. I was about to say, oh, I just did something with deck of cards. I could just copy all the code, but it's in JavaScript, so I can't. All right. So now for value in range 0 to 52, deck dot append dictionary. And then deck value dot set. Right? Set and get for dictionaries. I am not, for the record, not used to using dictionaries. It's one of the things I've been really challenging myself to push through. Add items. That's what I'm looking for. Oh no, you don't need set. You just right. You just call the thing. Okay. Suit equals um int okay, it's suits int value divided by 13. Value rank. Okay, so this is the problem. Because nope, that's not what I'm looking for. They go ace through king in hearts, ace through king in clubs, king through ace in diamonds, king through ace in spades. I'm sure there's a more clean way of doing this, but I'm just gonna say oh, the value is less than 26. That's a much cleaner way than what I was about to write. Oh, I'm overloading value. I'm just gonna replace that now. Okay, is equal to values card mod 13 else is equal to this value, but 12 minus that number. So when it produces 0, the first thing it does is give me a 12, and then 11, yeah, through 0. Yeah, that should be correct. Deck card facing equals false. Print deck. All right, let's see what we get. All right. It seems to be producing H. It produces heart through king. All right. And then the next thing is king of diamonds. So after king of clubs, it produces king of diamonds, then queen of diamonds, then jack of diamonds. Great. Okay. Cool. Okay. So now let's copy this instruction string. Okay. That's a lot. Now, if I remember correctly, Python strings are just lists of or slicing strings, actually. All right. So now we're going to enter into this giant while loop, right? While instructions dot. Oh no. I'm assuming I'm allowed to get the length of strings. String methods. Here we go. Oh, that's dot len. That's not dot. Yeah, string is an iterable, so it should be fine for this. Okay. So now we do a lot. So the first thing we want to do is we want to get the current instruction. Current is equal to instructions. Uh, yeah, the comma is 5. Yeah. Okay, cool. Oh, no, it's not. Is it def? This is my thing of like I haven't def. Okay, cool. Well, okay, is there I could just do like a switch or a bunch of ifs based on this and put it in the while. Yeah, there's no reason to do a separate function. Okay. Does Python have a switch or do I just have to do if elif? Okay, cool. Oh, I was looking at this. Okay. Oh, okay, match. Great. Great. Sorry. It is match current case 0. And I don't need to have like any end statement. I just use the let me actually just do this just so I can make it work for the moment. 5 1 2 3 4. Great. Okay. So this does the manipulations, and then after that, uh, instructions equals. Yeah, this doesn't just. Okay, yeah. I'm assuming returns a centered string. These are fun things to know about, but I'm pretty sure it's just make trans. Man, I wish I had that function. Um, yeah, okay, cool. So we're just doing the um slicing strings. So we're going to do from 1 to the end. I'm just gonna put this here just because I don't know the truthiness of Python off the top of my head. And that seems okay. Yep, okay, cool. All right, so then this should work, and now we can do the different cases from here. Okay. Some of these should just work. This is 4. Yeah. Okay. Actually, most of these should just work, honestly. Cool. Is it not like this dot pop? Oh, I'm using get. Oh my god. Jen. Again, the last thing I did was JavaScript. Oh my god. Okay. And JavaScript has dictionaries with get and set. All right. Uh okay, it doesn't like this. So okay, can I not can I do I have to say yeah, okay. I have to do it like this. Make a copy pop 0 pop. All right. That's easy enough. How are you feeling now? Great. Okay. Discard top card is super easy. Okay. This also should seem super easy. All right. Okay. New deck equals deck. For inputs in range 0 when deck. Oh, okay, we need to fix this. This is len deck, and this is len deck. Great. Uh, Deck equals new deck. All right, let's see if this worked. Oh, right. We were going to change this to ints. Yeah, it was delete this and then put int here. Oh, see, that's a good reason to do that. I wasn't even thinking about that in float versus. Okay. Well, that's a problem. I now have two. I have a lot of aces of hearts, actually. Okay. All right, I'm going to define print deck. This is a quick function for playtesting purposes. For card in deck. Let me define output string. Okay, for card in deck. Output string equals output string plus oh, I have to put it because it's a string. Yep. Let's just do that for the moment. Okay. Oh, I have to put it earlier. Okay. Oh, right. I'm iterating over objects, not numbers in this one. All right. Well, now we get to find out which one's the where the issue is. All right. Huh. So it's overwriting 7 of Hearts multiple times. Yeah, okay, so it is referring to the same underlying object. All right, so what I think I need to. So I bet 1, 2, and 4 are going to work, but not 3. Yeah, 1, I don't remember what they do now. 1 puts the top card on the bottom. Great. Okay, I'm back. I have food in me. So I was testing these, and I think 3 is not going to work, if I remember correctly. Yeah, okay. Yep. All right. 4 just changes the facing. Oh, I should. Well, we'll deal with that. No, let me actually just do with it now. No. Okay. Yeah. If car. Output string. Oop, nope. Output string plus up. Else. Down. So now if we run this, it puts that up and everything else down. Great. Okay. Okay, so this part isn't working. So if we go back to lists for a second. Just stick an iterable. So can I do? Does that work? Oh, that's not. That's not the thing I was looking for. All right. Yeah, that creates a new list, and then I don't care if this deck references that one. That's fine. I'm going to make these lowercase just to make them easier to read. Yeah, the parts that I'm checking look correct, so this is probably fine. So then I just need to do this. And then we'll run this on a 3. And this should flip the top and the bottom, and it does. Great. Okay. So let's rock and roll. Well, this looks, this is probably correct. Now, I don't remember exactly, I remember how the extraction works, but not, I'm just gonna, okay, do that. But I remember the suit is irrelevant. It's whether it's up or down and the number. So we have 9 up, 9 down. 9 up is a 9, which is an I. 9 down is a. Oh, wait. What am I doing? I have a program. I could do this. Uh. CHR. Okay. Oops. You need to see my background. Uh. Character is equal to. Oh. Hmm. Okay. How to go about this? I have this. Can I look up what value in a tuple? Index. Great. Uh, actually, do 65 plus uh values dot index card value. And these are all set to false at the beginning as face down. So plus 13 times. We'll see how this. We'll see how much it likes this. Oh, okay. So that worked. So what if I just do that? Virginia County. There we go. Okay. All right. Yeah, I can just get rid of that. Actually, don't need that. So anyway, that is solving prestidigitation via code. It took, well, this, I was gonna say 71 lines of code, but that's not correct because this is all comments. So like 60-ish. There's a bunch of extra white space. All right, 69. It took 69 lines of code. There we go. All right. Yeah, sorry I'm not the most like experienced programmer, but part of this is journey of learning and being vulnerable about where I am and where I'm not. Um, I hope that you enjoyed this. If this was useful, please let me know in the comments. If it wasn't useful, also feel free to let me know. If you like this video, please like, drop a subscribe. Yeah, because apparently I'm doing this now. Thanks a lot for watching.